Now we're going to look at the law of cosines. Again, you're going to want to take some notes on this, something that you'll be able to reference later, in particular the formula. Now the law of cosines is interesting because it seems very complicated, but it's actually just the Pythagorean theorem on steroids. So let's take our c squared equals a squared plus b squared. And that is the Pythagorean theorem. It says whenever you have a right triangle, then you can have a side A, a side B, and a hypotenuse C, and you can calculate C by taking a squared plus b squared and then square rooting it so you can get C. Now, that works great whenever you have a right triangle. The problem is that not all triangles are right triangles. So, what do you do when this is not a right angle? They added this little correction that allows you to say minus 2 times A times B times cosine of angle C. Not side C, that is big angle C. So if you add this little modification here at the end, now you have the law of sines. So let's draw ourselves a new triangle. Let's imagine that we have a triangle that looks something like this. And we have angle C right here, we have angle A, angle B, and then across from all these angles is their corresponding side. So little c, little a, and then across from b, little b. What this says is whatever angle you know, you can take the side across from it and call it c. So if you knew this angle right here, you could go across from it, take that little side, and then take the other sides, and as long as you know as long as you know 3 of those 4 pieces of information, you can use this formula to figure out the one that you don't know. So the best way to get experience with this is just to learn by example, but this diagram might be something that helps you. So if we jump down to this first example here, we need to find the side AC. Now I'm going to give it the name little b. However, before I do that, I'm actually going to rename everything in my triangle, and I will explain why in a moment. The formula for law of cosines is set up to assume that you know angle C, or you are trying to find out angle C. And in this case, the angle we know is right down here. So I'm going to call this angle angle C, which makes this side little c. Makes this angle, let's call this one A, this one B, and this would be side A and side B. A and B are completely interchangeable. It doesn't matter which one is which, so that doesn't really matter. It's C that matters. C is the one where you know the angle or you want to know that angle. So here we have our triangle set up. I completely relabeled it, screwed out the original labels because they were not helping us. And I'm going to set up my equation. I have the formula right here. Let's go ahead and start plugging things into it. We have side C right here, little c, and that is actually unknown. So we're going to leave that as c squared. Now going across, little a is 17. So 17 squared plus little b is 22. Minus 2 times 17 times 22 times cosine of my angle, 143. Now, we need to type all of this in our calculator, get c squared alone, and then once we get that, we need to square root it to get c. I highly recommend that at this point you type the entire thing into your calculator in one continuous string. You type it all at once. Reason is that a lot of times weird things happen with this last piece if you mistype it into your calculator or you kind of lose track of what it means. We have 3 terms. We have this term plus this term minus this term here. So again, I recommend that you type it all in one line in your calculator. If your calculator cannot do that, I recommend that you find a different calculator to use. When you do that, you're going to find that c squared is equal to approximately 1,370.379. And now you need to square root that answer. So take your answer that you just got, square root it, and you're going to get that c is equal to 37.01 something or another. We're going to the nearest tenth, so if we round that off, it's going to be 37.0. Now let's make sure this answer is reasonable. If we look at our diagram and we put this 37.0 right here, it is across from the largest side. It is larger than 17 and 22, so that makes sense. Largest angle and largest side are across from each other. And within the context of this problem, it's kind of on the same scale, so it seems like a reasonable answer. Now let's move on to one where we don't know any of the angles, and we're going to do that with number 18. With number 18, we are again told to solve the entire triangle. So similar to the last section, we need to not just find one angle, but we need to find all three of them. Neat thing about Law of Cosines is it is particularly powerful in finding the things that are hard to find. Once we know one of the angles, then we'll have a pair across from each other, and we can use the much simpler law of sines to solve for the next one. And then once we have two angles, then we can just use the fact that three angles add up to 180 to solve for the third one. So we're actually going to use three different techniques to solve the three different angles. You could use law of cosines with all of them, but that would be an enormous amount of work that I don't think anyone wants to do. In a problem where you have free choice over which angle you can start with here, I always recommend that you start with the biggest angle, which in this case is angle B. The reason you want to start with the biggest angle is because if you don't, there's potential issues that can come up when using law of sines with a obtuse angle. So we want to make sure that we solve for that one first with law of cosines. So if I'm going to solve for this angle, I want to rename that angle C, which means that I need to rename the other ones angle B and angle A. And I also want to label my sides. Across from angle C is side C, across from angle A, side A, across from angle B, side B. And then I want to plug it into my formula. Thanks to copy and paste, I have that here. Now I plug things in. I know that my side C right here is 29. So I have 29 squared equals my side A is 21 squared plus my side B 13, square that, minus 2 times 21 times 13 times cosine of, well, we don't know what angle C is, so we're just going to leave it cosine C. This one can be a little trickier to solve because we need to start getting everything on the other side of the equation. So first thing, I have this entire piece is one term. They are all locked together until I can get that alone on one side. So I need to work on getting that whole chunk alone on a side by itself. To do that, I need to subtract away the 21 squared and the 13 squared. So if I subtract those to the other side, I'm going to have 29 squared minus 21 squared minus 13 squared equal to what's left over there, negative 2 times 21 times 13 times cosine of C. Simplifying this a little bit now, I can plug this into my calculator exactly as I see it and plug this part into my calculator exactly as I see it and leave it multiplied by cosine C. Now this minus sign here is out front. It is not being squared. So this is going to end up being negative, as is this going to be negative. They are not, you're not squaring away that negative number. So type into your calculator 29 squared minus 21 squared minus 13 squared, and you get 231. On the other side, you have negative 2 times 21 times 13, and when you plug that all in, you get negative 546. Now remember that negative 546 is being multiplied by cosine C. Not added, not subtracted, is being multiplied. Reason that matters is your next step is to get cosine C alone, which involves division, not subtraction. So divide both sides by negative 546, and that part will cancel from both because it's just multiplied over there. And now we have the cosine of C alone, and it is equal to whatever 231 divided by negative 546 is, which is approximately negative 0.423. Whenever you have a number between negative 1 and positive 1 equal to a sine cosine, you know that you're probably within the right range. Those numbers should always be between negative 1 and positive 1. So finally, we want to undo the cosine because we have C inside that we want to get to. It is stuck inside the cosine function. So we need to undo this entire side, taking an inverse cosine, and do the same thing over here, an inverse cosine of that. The inverse cosine and the cosine cancel each other out, leaving us with just a C over on the right side. On the left side, we would take that inverse cosine of our last answer, and if possible, you can do that in your calculator without retyping it so you don't round the answer. Most calculators have an answer key. And it should come out to 115.028, and there's a bunch of decimals there, but we're going to round it off to the nearest tenth. So we're going to say 115.0 degrees. And so we go back here, we put our 115.0 degrees on our diagram. Looking at the picture, it looks like a slightly obtuse angle, so 115 seems totally plausible. Looks like we have the right answer. Now, again, we have a lot of work ahead of us because we have to solve for another angle before we can get to just adding them up to 180. So let's take a pair here. Say this and this pair can go against this and this pair right here. My unknown is an angle, so I'm going to put the angles on top. So I have my sine. I'm going to use law of sines because it's easier than law of cosines, and I have pairs on at least one pair of opposite sides. I have numbers. So sine of 115.0 divided by 29 is equal to the sine of b, which is unknown, over 13. So we sine of 115 over 29 equals sine of b over 13. Law of sine says take the sine of the angle over the side length. Now we want to get sine of b alone. We want to get b alone, but first we need to get sine of b alone. And to do that, we multiply both sides by 13. And these are going to cancel each other out, leaving us with just sine of b is equal to all of that. Last thing, we need to undo the sine operation to get b alone, because our real goal is to isolate just b. And since it's trapped inside the sine, we need to take an inverse sine of both sides. Inverse sine of all of this stuff. The sine and the inverse sine will cancel each other out right there. The reason this sine and this inverse sine don't cancel each other out is because there's all of that other stuff along with it. If it was just a sine and inverse sine on the side, it would, but all that other stuff causes it to not directly cancel. So now we need to type this into our calculator. And the way that we do that, we have our inverse sine first, and we open up our parenthesis, and inside we have our 13 times the sine of 115, and close that parenthesis if you have one, divided by 29. And then we will close the big parenthesis there. So go ahead and type that in. My calculator says 23.97, and since we're rounding the nearest tenth, that's going to be to 24.0. And that's a side length, so that is an angle actually, so we do need degrees on that. We solved for angle B, and that's going to be 24.0 degrees. So we mark that in there. Looks like a pretty small acute angle, so it seems like a reasonable answer. And then we still have angle A to solve for. So angle A is going to be our easiest one because we now know one angle, two angles, and we know that three angles in a triangle add up to 180. So if we take 180 and we subtract 115 and then we subtract 24, 180 minus 115 minus 24 is going to equal 41 degrees. So angle A is 41 degrees. That seems reasonable. Shortest side across from shortest angle, longest side across from longest angle. It looks like this all makes sense. And so our solved triangle would include all three of these angles that we had just calculated using law of cosines first, then law of sines, and then just adding up to 180.